Eighth grade, lesson 12.1 is the Pythagorean Theorem. Useful little tool that you could use when you're dealing with right triangles. So let's go ahead and address some right triangle vocabulary that goes along with this. Okay, and a right triangle is a triangle that has a right angle in it. And you have these two line segments that attach to the right angle have the name called legs. So those are the legs of the right triangle. And the opposite line segment away from and not touching the right angle at all is called a hypotenuse. Probably a brand new word for you. Hypotenuse is the line segment that's opposite where the right angle is at. And so a lot of times, probably, when we have these sorts of triangles on a graph, we can see exactly what the measurement of this is on the graph because you can count the boxes, and this one on the graph because you can count the boxes, but this one goes across diagonally across a bunch of boxes. So that becomes sometimes a little bit problematic on how to figure out its length. The Pythagorean Theorem helps us be able to figure out that unknown length. As long as we know the legs of the right triangle, we can always find the hypotenuse when we've learned the Pythagorean Theorem tool in our toolbox. And there's a couple of things in your toolbox I'm going to need to dust off cobwebs too, because the Pythagorean Theorem will use these. The first thing you've been using regularly, so there's probably not a lot of cobwebs on it, is the idea of inverse operations to solve for a variable. So if I have 3x equals 12, I want to isolate the variable. I'm going to use the opposite operation, the inverse operation of multiply by 3. I will divide by 3, right? And if I do that to one side of this scale that says it's equal, I need to do that to the other side of the scale to keep it equal. 3 divided by 3 is 1. That leaves me with 1x isolated. 12 divided by 3 is 4. Inverse operations to isolate a variable is still a tool you will use in this section. It's a tool you'll use all the time. That one you've been using, so I think that's all very, very still fresh in your mind. The one that we covered at the beginning of the year that's coming back at us that might have a few cobwebs on is square root. So we'll do a quick review of that. So 2 times 2 is like saying 2 to the second power, 2 times itself twice. And as you well know, 2 times 2 is 4. So the square root, what two numbers multiply together to give me 4? The square root of 4 is 2. 3 times 3 is 3 to the second power, right? And you know 3 times 3 is 9. So the square root of 9 is 3. 4 times 4, I'll only do this a few more times just to get it nice and solid in your brain. You know that 4 to the second power is 16. That means that the square root of 16, what number multiplied by itself gives us 16? Well, 4 does. 5 times 5, this is the last one that I'll do. 5 times 5 is 25. So the square root of 25 is, you guessed it, 5. Okay, so dusting off that cobweb because we're going to need the square root skill. And the reason we're going to need that is if I have something like c to the second power equals 36, let's say. Taking this piece of knowledge and this piece of knowledge and putting those together, I again want to isolate my variable. One variable only, right? I don't want 2 of them. This is saying 2 c's, c times c. I only want 1 c. The inverse operation to square, the opposite operation to a squared, is a square root. So if I want to isolate my variable on this square, I need to use inverse operation of square root of c to the second power, and that will give me c by himself. But as you well know, if I do one thing to one side of the equation, I must do the same to the other side of the equation. The square root of 36 is 6. So I wanted to clean this, refresh your memory on this, clean up your memory on this so that we could tie those together to see, oh, square root is the inverse operation of a square, because we are going to see a lot of those in this lesson. So I wanted to tie those together. Okay, so I want to familiarize ourselves a little bit again and look at some details of a right triangle. So I have this right triangle. I know it's a right triangle. It has the little bitty box that indicates that's a 90-degree angle. I can count 1, 2, 3, 4, the length of that side. And I can count 1, 2, the length of that side. But getting this value is harder because it's going like partially across here, then partially across here. It's not going to be very accurate. It's going to be off a little bit. And I'd like it to be somewhat precise. So let's look at this in terms of pretending that each of these sides are a part of a square off to the side of it. So I'm going to draw some squares. A square that has 1, 2, 3, 4 sides all the way around. A square that has 1, 2 sides all the way around. And then a square that kind of matches this over here. Okay, there I've drawn those. And notice that this whole area, oh, and I've labeled them too. I called this this side length A. And of course it's a square, so that side length would also be A. So with this and with that. I've called this side length B. And so of course the square that attached to him is going to be B, B, B. And I've called this hypotenuse side length C. And of course every side length across there is going to be C. And if you notice, I have 16, right? 4 times 4. 16 as my area here. And then 4 more as my area here. 1, 2, 3, 4. And then over here, it's hard to count, right? Because I have all of these diagonals in there. But it almost looks like this. If you put these two together, it would be about that size, about 20. All right? So it does look like that could be the case. And as it turns out, it is. So since Mr. Pythagoras learned that, we can use that to our advantage. So here's how we're going to piece this apart. We're going to say that we know the area of this square A, right? It's A times A, right? If the square's area is at one side times the other side. So we're going to take A square, A to the second power, which by the way, we do know is 16. Well, let me back up a little bit and just take it one step at a time. We know that side length A is 1, 2, 3, 4. And we know that 4 to the second power is 16. Okay? Then we're going to take B, which is 2 squared. And 2 to the second power is 4. And like we said, we noticed that it looks like if you push these two and these two in here and mold them, they will fit right into that. You'd have to adjust, right? We could take that the one side here, the A squared would fit here, and then split this all up, and it would split along the side. It would fit together, so it would equal C squared. So A squared plus C squared, or A squared plus B squared, the area of A and the area of B, all together will fit in as the area of C. Okay, well then we take what we know. We know that the area is found by one side times the other. 4 squared, we get 16. One side times the other, 2 squared, we get 4. And we don't know the side lengths of C. That's the whole point. That's what we're trying to find out. Let's add 16 plus 4. That's 20. Okay, here's where that comes in, where you're using inverse operations to isolate the variable. That variable is C times C, and I only want it to be C. So the inverse of square is a square root. So I'm going to square root C squared to get C. And if I square root one side, I must square root the other. And obviously 20 is not a perfect square. Hopefully your brain recognizes that by now. Have a calculator handy for this lesson. You do not want to be trying to do these square roots with all of these practice problems we have to do without a calculator. So make sure you have a calculator handy. If you don't have one on your computer, go to Desmos Scientific Calculator and use that. Your phone can be used as your calculator. If you didn't already know this and you've been using your calculator on your phone in a vertical fashion, turn your phone horizontal and it will pop up with a bunch of other functions And you will see square root on there. Usually looks like that. So in my calculator, I'm going to type the number 20. And then I'm going to hit that button that looks like that, what I was just talking about, square root. And I will get 4.4721359549999957. Probably goes on and on forever as an irrational number with no repeating pattern going on. Round these numbers off. I tend to round them to the tenths place just to keep it simple. So it's 4.47. I will call it 4.5. The length would be 4. It would be about, right? So let's use that equal sign that's squiggly because we rounded it. So about 4.5 units in length. So what I'm going to ask you to do is file in your memory banks. Think about the fact that you want to file this away under the folder triangles in your memory, the file cabinet in your brain. And under the subcategory of right triangles, if you want to find the length of the hypotenuse, use the Pythagorean theorem. The Pythagorean theorem formula is a squared plus b squared equals c squared. Say that 10 times. A squared plus b squared equals c squared as the Pythagorean theorem to find the hypotenuse of a right triangle. And you will find, maybe it's not something used often, but it does come back at you in life. And if you ask many adults and you say, well, what's the Pythagorean theorem? They probably had to say it several times and memorize it, and were told to memorize it. And they probably can say something like, oh, it's something about a square and c square and b square. Like they'll remember bits and pieces of it. I mean, they've learned it. It's in there. There's a few cobwebs, but once somebody points it out to them, it's right back in their memory banks. And that's what we're trying to do for you. Make sure it's there so it's a tool you can access on the weird occasion. And well, depends on what career you go into. Some careers you're going to need it all the time. Some careers it's going to pop up on a weird occasion like, oh my gosh, I never thought I'd need this. And here I am in a position where Mr. Pythagoras has become useful to me. So a squared plus b squared equals c squared, Pythagorean theorem. Okay, so I showed you one of the ways that my brain was able to make sense of a squared plus b squared equals c squared with the squares attached to the side. That had been shown to me at some point, and for some reason it didn't get shown to me in my 8th grade math like it is with you guys. It was shown to me way later, and that was the one piece of information I needed to go to understand that concept. Otherwise, it was like, I memorized it, teacher, I can do it, but I didn't understand why it worked. So that made sense to me. The book has another way they want to show you too about what proves that this works. And this would involve, this. I think this will make better sense if you actually do it, but they do give us the formula, a squared plus b squared equals c squared, right? There they give it to us, Pythagorean theorem. In a right triangle, the sum of the squares of the lengths of the legs is equal to the square of the length of the hypotenuse. That sounds super wordy. A to the second power added to b to the second power will equal c to the second power, the hypotenuse to the second power. And then you just fill in what you know, calculate, 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 inverse operation, square root, and you're good. So here's what they've done with this. If you actually cut these triangles out, it may help. So they draw a right triangle on a piece of paper and cut it out and make one leg shorter than the other. So I have this right triangle with long leg, short leg. This right triangle, right angle, short leg, long leg. And let's go ahead and label them. They say trace your triangle onto another piece of paper 4 times so that you have all 4 of them. And label the shorter leg A. So on each of these, that's the shorter leg, that's the shorter leg, that's the shorter leg, and that's the shorter leg. And the longer leg B, that's the long one, that's the long one, that's the long one, that's the long one. And the hypotenuse C. C, 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 C. So then they ask us, well, what is the area? If you place them all into a square, you have this big open unshaded area here. What's the area of that? Well, it's a square, right? It's a perfect square. So I would take one side times the other side, C times C, which is C to the second power. So what's the area of the unshaded part? C to the second power. Okay, and so let's put the area in there. All right, so now you would trace this shape on a piece of paper underneath it. Trace the shape. Then, and there it is. Then rearrange these cut triangles already cut up. Rearrange them and place them with the B length facing down on one and the A length facing down on the other, and you'll find that you get them to fit nice into rectangles, nice and neat, right? So I have this square and I have this square. These are perfect squares up here. So let's have a look at those. So we know that the length of this matches the length of that. This is B, and this is B. So this is B square. And on this one, the length of this is A, so the length of this is A, and A. So the area of this is A square. And because it was the same size box as this, and we just moved these cutout triangles into different arrangement, it's still the same amount of empty space. This amount of empty space is the same as this empty space. A square plus B square is the same amount as C square. So this is another handy dandy way to kind of tell your brain, really, for real, it's true. You'll just memorize this, but it's not ideal to just memorize things and not know why it works, because your brain will remember things better if it knows why it works. So that the way I showed you and the way they've shown you that A square plus B square equals C square should help your brain accept it and then decide it's worth memorizing because it makes sense. All right, now that we've shown our brain that works, let's use this tool. So we have this right triangle. I know it's a right triangle. I should have put that there. I know it's a right triangle because the little box says it's 90 degrees. I have a leg length that is 7 inches, a leg that's 24 inches. It doesn't matter which we call which, but we'll call that A and we'll call that B. So A square is going to be 24 square. B square is going to be 7 square. Is going to equal C square. Pythagorean Theorem says so. Okay, order of operations says those exponents have to be cleared first. So 24 to the second power, I used a calculator, 576. 7 to the second power, that one I have memorized. I did not need a calculator. Now I add those two together. They add together to 625. And here we are at that inverse operation to isolate the variable. I have the variable c to the second power. I just want c. So do the square root. The opposite of a square is a square root of c square. And if you're square rooting one side of the equation, you must square root the other side of the equation. If you don't know what the square root of 625 is, then in the calculator, if you're using your phone, turn it horizontal on your calculator, type in 625, and then hit the button that looks like that, and you will find that 25 is what c equals. Ta-da! Let's look at another example, and you might find a little bit of a twist on this one. No worries. Remember, these are the legs of the right triangle, and this refers to the hypotenuse. Notice over here they gave me a leg attached to that right angle, and I don't know that one, but I do know the hypotenuse. Okay, if I know two of them, I can solve for the third. So let's call this one A and this one B, and we know this one is C. And let's fill in the information from the Pythagorean theorem. A square, that's 12 to the second power, plus B square, I don't know, that's the one I don't know, equals C square. Oh, that's 15. Okay. I get my calculator, unless I know what 12 square is. You might already know. 12 to the second power is 144, plus B square, I don't know, equals 15 squared. That one I don't know in my head. 225. Okay, inverse operations to isolate the variable. We see our variable is b to the second power. Let's pull this 144, this positive 144, away from b first. So I will subtract 144 from this side, and if I do that to one side of the equation, must do to other side of the equation, right? And I'm going to get 81 equals b squared. And now I need the inverse operation to isolate the variable b. He's being squared. The inverse operation of squared is a square root. That will give me b, and I need the square root of 81. You might know that one in your head just fine. 9. The length of b is 9. So sometimes you'll get the measurement of the legs, and you can just fill in a squared plus b squared equals, and then find for c squared. Sometimes they'll give you the hypotenuse and one of the legs, and you've got to find the other. And this was just to show you, you could do that either way. If they give you two sides, you can use that formula or that theorem to solve the third side. Okay, and then this lesson kicks it up a little bit of a notch. Same concept. There's a little more visual issues coming up, which you well know is a weakness for me. That doesn't mean I give up on it. That just means I chew more slowly to digest the information. I tackle it more slowly and carefully. So here we have Tina ordering a replacement part for her desk. It was shipped in a box that measured 4 by 4 inches on the base and 14 inches in length. What's the greatest length in whole inches that the part could have been? So if you place it in the box as most diagonal as you can get across this R from this corner to the back corner and diagonally, that's the longest that piece can be. It can't be more than that. It would be poking out the sides, right? That's the longest length that can fit into that box. So that's what we're going to try and find. Now, this is a diagonal of a diagonal, and what a mess. So we're going to take one bite at a time. I'm going to look at the very bottom of this box, like cut it out and just look at this rectangle only. And because my brain doesn't like the visual pieces, I draw that bottom of that box for my brain. And I know that it's a 14-inch length and then a 4-inch right here. This is representing just this bottom of this box in flat form, so my brain likes it. And S is my hypotenuse. So we want to first find this length, because once we know this length, then we can use that times the 4 here for this triangle to find the hypotenuse of that. So we've got to find the hypotenuse of 1, of the bottom of the box, find the hypotenuse of 1 to get that length so that we can get the hypotenuse of another. Tricky, but you have all the skills to do it. So focusing just on this triangle. So let me put this 4 inches over here. A squared plus b squared equals c squared. A, let's call this one A, let's call this one B. We have the legs, right? That's a right triangle. We have the legs. 4 squared plus 14 squared equals S squared. We'll change that variable to the variable they have listed for us here. We're looking for that distance right there. Okay, and 4 to the second power is 16. Whoopsie. 16. 14 to the second power I did on the calculator, 196, is going to equal S squared. Add those together, and you're going to get 212. And then to isolate this variable, I need an inverse operation, inverse of square. You probably catch this now, square root, both sides. S is going to equal the square root of 212. So on my calculator, I'm typing 212, and then the button that looks like that. And I get 14.56021977856104, probably on and on forever as an irrational number without a repeat. Square roots many times do end up as irrationals. Round it to the tenths or hundredths place. Round it to keep it simple. It's 14.56, so I'm going to call that 14.6 inches. So S is 14.6 inches. Okay, that gave me a step closer. Now I will focus on this triangle because I know this length now and I need this hypotenuse. So for my brain, I'm drawing that flattened version of it. I know now that this is 14.6 inches. I know that this one here, meaning this one here, is 4 inches. And I need this R length. Using my Pythagorean theorem again, a squared plus b squared equals c squared. Let's call that A, let's call that B. 14.6 squared plus 4 squared equals, now instead of c, let's use the variable r that they have there so my brain knows what's going on. 14.6 times 14.6 ends up being 213.16. I've been rounding things to the 10th power. I'm going to keep doing that. 213.2. And 4 to the second power is 16. Let's add those together. It's 229.2 equals r to the second power. And now inverse operation to isolate the variable. It's being squared. The opposite of square is square root to both. On the calculator, type in 229.2 and then push that button. And you will get 15.139352694220045, on and on forever. You see why I told you make sure you have a calculator for this. Round it, that's 15.13. I'm going to call it 15.1. So my length of r equals 15.1 inches. That's it. So that kicked it up a notch, but it's not anything they're adding new information to. It's just recognizing I've got to do this a bite at a time. I'm not shoving this whole waffle in my mouth and trying to swallow it. You've got to chew this up one step at a time, one bite at a time. So we did this bite first to find that. And then once we found that, we could do this step next to find that. So sometimes multiple bites have to happen. You can't just shove it in your mouth. Okay? That's it for this lesson. It's not easy. It gets easier with practice. And just keep practicing it, walking through the steps. Review this as many times as you need to get it clicked into place, or ask me if you need help.